the derivative with respect to x of a times a function of x to the n is equal to an times the function of x raised to the n minus 1 times the derivative of the function of x. In other words, multiply by the derivative of what's inside. Does anybody have any specific questions you would like me to go over? Go ahead, Grant. 1h. So we have 4 over 9 minus x squared as a square root. And I would say that this is a classic kind of thing that we would be expected to differentiate. It's not, in other words, this isn't an advanced one or a trick one. We just need to see how it's done so we learn from it in case we see something similar in the future. I'm going to rewrite this, first of all, Grant, as 4 over 9 minus x squared to the half. And I'm going to ask people, how many of you did this problem already? How many of you did it using the quotient rule? If you did it using the quotient rule, that's not incorrect, but there's a simpler way to do it. Because this is a constant, the numerator here does not depend on x. It's to your advantage to move this denominator to the numerator and write it with a negative exponent. And I am not quite sure why I put squared there. This is to the 1/2. And I think I misspoke a second ago. So we have 9 minus x squared to the 1/2 in the denominator. We're going to move it into the numerator where we're going to have a negative exponent. I believe I said positive a second ago. So to begin with here, Grant, are you okay with the fact that these two things are the same? Okay. Because of that, I can use the power rule here. This is just for me because I just thought of something that I want to talk about in a minute. I can use the power rule here by multiplying that negative 1/2 by the 4. So now I'm into the dy dx mode. Negative 1/2 times 4 is negative 2. In the power rule, the base stays the same. There's a temptation to maybe differentiate that base and write down the derivative of it, but that's not what we do. You write the same base, and it is then raised to 1 less than the original exponent. So the negative 1/2 went down in front, multiplied by the 4 to get negative 2. I take the negative 1/2 and subtract 1 to get negative 3/2. You're okay so far? And then I multiply by the derivative of what I wrap the exponent around. So now again, everybody, I know you know this, but I hope you respect and appreciate it. I'm always pushing you to learn a little bit deeper. All you need to remember to be functionally literate at this point in this course is you have to multiply by the derivative of what's inside. That's it. That's the chain rule. But the chain rule in a broader sense says you multiply by the argument around the rule you applied. You applied the rule around 9 minus x squared, so we multiply by the derivative of 9 minus x squared. We're pretty much done here, Grant. I can take that negative 2x and multiply it by this negative 2 in front and write 4x, and I would probably rewrite this now with positive exponents in order to get that for an answer. Is that okay, Grant? Okay, good. Now I want to show you something else here, and it had just occurred to me. Imagine that I had the following. And I said, I want you to find the derivative of this. Okay, so just, if you are working, that's good that you're working, but just pay attention up here for a few minutes. I say find the derivative of this, and you go, well, I'm going to move that bottom thing up to the top. which isn't wrong. I don't think it's the smoothest path you can start walking down, but it's not wrong. So this is correct. And what I'm going to write in the next step is incorrect, but it's something that many of you will do at some point. You'll think you can do it. You will look at this and go, I'm going to take this exponent and multiply it by what's in front. I'm going to write the base, and I'm going to drop 1 from the exponent. Which, by the way, and even if you said and multiply by the derivative of what's inside, that is not correct. Why can I not multiply that exponent by what's in front, rewrite the base, and drop 1 from the exponent? The reason is that that rule only works when you have a number times a variable to a number. You're allowed to do that. That's the power rule. But you can't do that in this case because the coefficient is variable. It's not a number. In other words, you would have to, if you started down this path and wrote that, you would have to use the product rule, which in my mind defeats the purpose of bringing it up. Just use the quotient rule to begin with. So I mentioned that because somebody's going to do it sooner or later, and I'll go, oh, wait, remember this? You can only use the power rule if the coefficient is a number, not a variable. Other questions? Grant. 1K? I had mentioned yesterday that many of these questions, 1K is one of them, are really just a test of your patience in applying the chain rule. So when you take a look at K, and I had also mentioned that, let me write this down first. I had also mentioned that when you differentiate some of these, K being one of them, it's not like you're going to be able to simplify this into some tidy little package. It just won't simplify. All I've done to begin with here, Grant, is I've rewritten that fifth root as an exponent of 1 over 5 because that's the meaning of a root. And I want everybody to notice that what we have is a difference of things, right? If you want to be very pedantic about this, very picky, this is what we have. We have y is equal to x minus that other thing. So when you are asked to find the derivative of a difference, all you do, please don't ever write this on an assignment or an exam, but all you do is you ddx everything. I mean, if you're going to write that, then rewrite it as ddx of y equals ddx of x minus ddx of that other thing. It's because of this minus sign that we are allowed to do that. So this is dy dx. What is the derivative of x with respect to x is 1? Minus, how do we find the derivative of this thing? Well, this thing is a power. It's a base raised to an exponent, which we call a power. And it's found, the derivative of that is found by wrapping that exponent around the base, which remains the same, dropping 1 from the exponent. So 1 taken away from 1/5 is negative 4/5. Is that right? Yeah. And then the chain rule says I have to multiply by the derivative of what's inside. So now, what's inside? What's inside is a sum. 1 plus x to the 5 plus negative 6x to the 10. And the derivative of a sum is the sum of the derivatives. In other words, what I did up at the top where I wrote those black d dx's, I'm going to do to everything inside the brackets down here. The derivative of that is 0 plus 5x to the 4 minus 60x to the 9. And we're done. Every set of brackets that I have there is important. This is not simplified for so many reasons. One of the reasons is there are fractions as coefficients, and anytime there are fractions as coefficients, we would much rather have it as a whole fraction with one thing over another. I'm not going to do that. It's also not simplified because we have a negative exponent. But that's the answer. Okay, we have, I like y. Y equals 2x plus 1 multiplied by 4x minus 1 to the 5. And we have two options here, one of which is out the window immediately. You can expand that all out so that you could have a big long polynomial where you can apply the power rule to each term. But the thought of doing that and then being expected to take your derivative and factor it is way more trouble than it's worth. So we're going to use the product rule where this is the first and this is the second. So dy dx is equal to the derivative of the first times the second plus the first times the derivative of the second The derivative of the second is found by applying the power rule to 4x minus 1 to the 5 and getting 5 times 4x minus 1 to the 4 and multiplying by the derivative of what the base of the power was, what the derivative of the argument of the function. And I'm on autopilot like I am most days with this, so I'll just double check. 2 is the derivative of the first, and the second is 4x minus 1 to the 5, plus the first, which is 2x plus 1, times the derivative of the second, and it all looks good. Okay, so now I'm back at that, not squinting my eyes so much that I can't see things clearly, but I'm just looking at the big picture here. And the big picture is I have a term minus a term. So I want to factor. Is there a common factor to these? Well, there's a 2 as a factor right here. And I'm not going to rewrite this 4, but I could rewrite the 4 as 2 times 2. There is a factor of 2 that it can be removed. I have 4x minus 1s here, and in this term I have 4x minus 1s. So this would be like, Liam, me having a to the 5 in one term and a to the 4 in another term. I can factor out a to the lowest exponent, which is 4. So I'm also going to factor out 4x minus 1 raised to the 4. And then I have left, this is the big set of brackets, where I'm going to have the leftovers from the first term minus the leftovers from the second term. Well, I take the 2 out of the first term. This is the first term. This is the second term. I take the 2 out of the first term, and I take 4x minus 1 to the 4 out of the first term. That leaves me with 4x minus 1. I think I might have just said 4x minus 4 to the 4, but I meant 4x minus 1 to the 4. I don't really need a set of brackets around that, but I just want to do this to indicate that that's the result from the first term. Minus, actually plus, I don't know where I got the minus from in my head, plus, I really had, and some of you might think better this way, I really had with the 5 and the 4, 20. And when I factor 2 out of 20, because I took the 2 out, I'm left with 10. I took out all of the 4x minus 1 to the 4's, and the 2x plus 1 is left over. So we're just about there, Liam. All we have to do now is take what's in this large set of brackets and clean it up, and we're done. So 10 times 2x is 20x. Well, I shouldn't say then we're done. We'll find out. 10 times 2x is 20x plus times the 4x times, what's going on here? Let me start again. 10 times 2x is 20x plus the 4x is 24x. Then I have negative 1. And then I have, let's see, 10 times 1 is 10. 10 and negative 1 is 9. How does that look? This would not be the answer, because we always want things factored as deeply and as much as possible. And after we took out, this is an interesting thing about factoring, after you take this out, and this was the greatest common factor, it turns out that when you simplify the result, you get 24x plus 9, which has a common factor of 3. So I can factor a 3 out of this and have 8x plus 3. And I think you know what's going to happen with that 3. It's going to join forces with the 2, and we'll have a coefficient of 6. So the final answer for my derivative here is 6, and we have the 8x plus 3, and then we have the 4x minus 1 raised to the 4. And again, the order in which you write these three things really doesn't matter. But that's probably how it would be written. Y equals the square root of x plus the square root of x. I just want to make sure that's how it appears in your text. Okay. So I'm going to rewrite that in exponential form as y equals, in brackets, 1 plus x to the half to the half. So this is that. And should it be x instead of 1? Thank you. Better? Okay. So then underneath that square root is x plus the square root of x, which is x plus x to the half. I wish I could come up with a different way to describe this, but again, I hope you get the drift of my intention here. When you look at this expression, x plus x to the half, quantity to the half, and you zoom in from far away, the first operation you bump into is the one I've highlighted in yellow, correct? And what I've highlighted in yellow, everybody, is a power. So I'm going to use the power rule with this as a base, remembering that I wrap the exponent around the base, which stays the same, and then I drop 1 from the exponent. So my derivative here, at least to begin with, is going to be 1/2 times x plus x to the half raised to the negative half. That's kind of the starting point. But because the thing we wrapped the exponent around was more than just x, we have to multiply by the derivative of that thing we wrap the exponent around, because that's the chain rule. And what we wrap the exponent around is highlighted with that red line under it. And that's a sum, which means I need to multiply by the derivative of that sum, which is the sum of the derivatives. So what's the derivative of x? That. What's the derivative of x to the half? That. And as far as I'm concerned, we're done. We're in the same general vicinity as we were with the question that Grant asked about, and then Arden and I talked about simplifying further. Could you simplify this further? Yes. There's no profit in it for us to do that. There's nothing to be gained by doing that. You could, I suppose, write that. And I've done a couple of things here. Because there's a multiplication sign in here, I am allowed to move factors between the numerator and denominator. So for example, 1/2 as a factor in the numerator can be written as just 2 in the denominator. That x plus x to the half to the negative half, I can move it to the denominator with a positive exponent. And then within this, I just decided to write this thing as 1 over 2 root x. It's not entirely simplified, and we don't want to simplify it further. Good? Yeah? Oh. So this is kind of the same as what we just did, but it's one layer deeper. I think the difficulty with n here is going to be to keep track of what the brackets mean. So I'm going to start in the beginning, in the middle, and this is x to the half. That's this thing. And we're adding x to it. That's that thing now. And we're taking the square root of it. So that's that. But then we're adding x to it. So that's everything underneath this now. And then we are raising it to the half because we need to take the square root. Oh. And that's why. So dy dx, I have to deal here with this first. You know, rather than using the analogy of always saying when you zoom in from far away, the bottom line is you work from the outside in. So I'm going to have to wrap that half that I've written in green around the base, which stays the same, and drop 1 from the exponent. And again, this particular question, everybody, is not anything I would ever put on an exam. Not because it's too difficult, but this is a training question. This is a question that you're using to train your mind to the idea of the chain rule and orders of operations. It's called the chain rule, by the way, because this chain would, I believe, have 3 or 4 links to it. Now I have to multiply by the derivative of what I wrap the exponent around. And what I wrap the exponent around is this. And that's a sum. It's x plus something, which means I have to differentiate the two things and add them together. And this set of brackets I'm putting here is really important. I have to multiply by 1 plus the derivative of that other thing, because the derivative of x is 1. Now, the other thing, I'm just looking here right now, is a power. And that has a derivative found by using the power rule, which in this case is going to be to multiply a half by the base, which stays the same. I should be clearer there. The reason I'm multiplying a half by that base, which stays the same, is I'm taking this exponent and I'm moving it in front. I'm multiplying it by the coefficient of 1 that it currently has. The base stays the same and I drop 1 from the exponent. Now, right now, this thing here is supposed to be the derivative of this. And we find the derivative of this by using the power rule, but we're wrapping the power around something that is more complicated than x. We're wrapping it around x plus x to the half. And that means the chain rule says we have to multiply by the derivative of this thing now, because we wrapped the exponent around that. So I need to multiply this piece by the derivative of x plus x to the half, which is 1 plus 1 half x to the negative half. And we close brackets on that, and then we close brackets on the whole thing. I do not even want to begin to look at simplifying that. Before I cleared this from last year, I saw that last year I did simplify it, and there's a way to do it, but let's not. Is that okay, Arden? Sorry, Farhan, is that okay? Okay. Other questions? No other questions at this point in time? Okay, I do have a handout I'm going to give you with just some additional problems. I'm just kind of the opinion that with differentiation, the more practice you can do, the better. So I'm going to hand this out to you. Demi, I emailed this document to you. I'm pretty sure I emailed it to you. And if you have access to a printer, you can either print it out or just go with the online version. With this particular handout, it's just questions 1 to 8 that you know how to do. So if you look at 9, 10, or 11, you will not be able to do any of them. Well, you might be able to figure them out, but this isn't for homework. This is extra practice. You're welcome, Demi. You're welcome. Asked, is this handout full of questions that are challenge questions or not? And I would say no. I would say these are all things that you could see on an exam. There are some of them, perhaps like L, which turns out to be a test of your ability to work with rational functions from grade 11. So I wouldn't really consider L to be a calculus question, but I don't think there's anything when I look at, did yours print out like that? No? Okay. I don't think there's anything here really that is out of bounds. When you start to get to some of the word problems, you know, this is the issue we're going to have when we talk about exams, is I could give you a problem that asks you to find, for example, did yours print out with 7C like this as well? No? Okay, so this is just Google being Google. Some of these questions might require, like question 5, a bit of work, and that's the challenge we have is sometimes it's not hard work, it's just a lot of work. But I would say they're all fair game. I will hand back your most recent assignment. And Demi, I've marked yours and it's in Power School, but I haven't. Oh no, I think I did email you a scan of it as well. So you already have yours. Everybody else, I'll hand back yours now. Farhan?